Hello everyone. Hello everyone. Can you hear me?
Yes, sir.
Yes, sir.
Okay. So let me share the board with you. Okay. So yeah, it's great. Now, so welcome to the first session of Bose Spring Olympiad boot camp, and we will be doing some algebra today. And
Sir, are you going to record this meeting?
yeah, we will be recording this meeting as well. Thank you.
Sir, we will do algebra.
Yes, we will be doing some algebra today. Yes. All right, thank you. So I hope everyone is here now, and we can just simply start. Okay. So the thing about the first thing that we want to talk about talk in algebra is about equations and how we can use them to find out when the values of certain equations reach a certain level. So one example of equations you have seen belong to identities. So example of identity would be a plus b whole square equals to a square plus 2ab plus b square. Did have all of you seen this kind of stuff before? Let me ask you that.
Yes, sir.
Okay, so this
Yes,
is
sir, I have.
okay. So this is extremely simple. It's like this, that you multiply a plus b and a plus b, and what you get is a times a square, a times b ab, b times a b times b square. So we have a square plus 2ab plus b square. It's kind of simple. Things can become a little bit more complicated. Just do one thing. I just change the background a little bit. Okay, that's fine. Yeah, so things can become a little bit more complicated with a square minus b square becoming equal to a plus b times a minus b. So this, of course, all of you have seen something like this before maybe. Let's use these two tools to talk about a different identity, and this will lead us to a factorization of a to the power 4 plus 4b to the power 4. So what do I mean by factorization? I mean that you can write this as a product of two factors. One example of factorization was a square plus b minus b square equal to a plus b times a minus b. So each of these things are known as factors, and you multiply two of them to get a square minus b square, and you're kind of happy. Okay, so I'm able to write them as a product of two things. Now, can you do the same thing with a to the power 4 plus 4b to the power 4? Is it possible to do the same thing with a to the power 4 plus 4b to the power 4? Can all of you give this a try? Yes. And if you know the answer, don't jump and say it. If you have a question only, then raise your hand. Okay. Anushka, I'm assuming you have a question. Yes.
Yes, sir, we have to find the square root or any two factors.
No, you cannot use square root or anything. You have to just do plain simple factorization.
Okay.
Yeah. So can you use plain and simple factorization? Can you use plain and simple factorization to factorize a to the power 4 plus 4b to the power 4? Using the tools that you already know. So one thing is, this is a, so again I'll write the problem here so that you have it in reference. The question is factorize a to the power 4 plus 4b to the power 4. It's kind of always hard to work with the plus sign when you try to factorize something. You will always see it's kind of hard. So for example, if you have a square plus b square, it's a bit hard to do that. Why is that? Well, one thing you could do is you could use the formula of a plus b whole square equal to a square plus 2ab plus b square. And then you could take this plus 2ab to the left hand side, and you have a plus b whole square minus 2ab equal to a square plus b square. You can do stuff like this. So you can express a square plus b square as a difference of two things. Difference of two things. And what are those two things? One of those two things is a plus b whole square. The other thing is 2ab. So you could express a square plus b square as a plus b whole square minus 2ab. That you can do. But can you write a square plus b square as a product of two things? Well, in most cases, this would be very hard to do in terms of a and b. But you could do that with a to the power 4 plus b to the power 4. But how can you do it? So I see some raised hands. I'll go to those students. Aaron, Pallavi, Arav and Alpa. They have raised hands. Soham has raised hands. So if you have, if are you ask who, if you have a, okay, Aaron says that he has an answer, I guess. So Aaron, can you
Yes,
give
sir.
us the first step of what's going on? Well, how to do this?
So, sir, if you take a to the power 4 as a square whole squared,
Okay,
and
let's
if
do
you take
that. A
and
square.
if you take 4b to the power 4 as 2b square whole square,
Okay.
then if you take a square plus 2b square whole square, which is
Ah,
equal to a4 plus 4b4 plus 4a square b square. Then what you do here is you take the 4a square b square to the other side.
I see. So basically, what Aaron is saying is excellent. It's right, actually. What he's saying is that use this tool right here, the a square plus
Yes.
b square thing. So what you do is you write a to the power 4 as a square whole square. You write 4b to the power 4 as 2b square whole square. 2b square whole square. So you have something square plus another thing square, right? You have something square, that something is a square, right? And the another thing is 2b square. So you have something square plus another thing whole square. Okay, that's great. Now you use this a square plus b square formula that we just created. A square plus b square is a plus b whole square minus 2ab. That's what we got. So let's use that. So this is something plus another thing whole square, because that's what's going on here. A plus b whole square means you take the first thing and add it to the second thing and square it, and then subtract from that 2 times something times another thing. Right? So let's replace the stuff that we have here. So we have a square plus 2b square whole square minus 2 times a square times 2b square. So that's what a to the power 4 plus 4b to the power 4 is all about.
Sir, it is 4 into a square into 2b square?
It's 2 actually. It's 2ab, but it becomes 4 because the two 2's get multiplied.
Oh, yeah.
So you get a square plus 2b square minus 4a square b square. Okay, now I will give you a couple of minutes time to the people who are just catching up. Those of you have already done, that's easy for them. But if you are seeing this for the first time, then I'll give you a little time to catch up. If you are joining right now, this is the Bose Math Olympiad Spring Intermediate Boot Camp, and we are working on algebra. If you are not registered for the boot camp yet, and I strongly recommend you do that so that you can attend the next boot camp, and which is coming up next week, and then the contest. Also, the students who are attending the boot camp, I'm telling specifically to you that there are 2 rounds of it. The first round would be the individual round, and the second round would be the team round. So in the team round, you will need 4 team members who will be working together. Now, you can find team members from your own school. That's fine. Or your friends, or somewhere, if you know someone inside Cheenta, some of your other friends, that's fine. So that's the second round of it, the team round. And there will be a boot camp before the team round as well. Okay. All right. So now what we have here, let's write it a little bit carefully. What we have here is a square a to the power 4 plus 4b to the power 4 equal to a square plus 2b square whole square minus 4a square b square. So, or a square plus 2b square whole square minus, so you can write 4a square b square as 2ab whole square. Okay, so now the question is, what would be the next step? I'll go to Shoham Pednekar and I will ask him to tell me the next step. Or maybe someone else. Arav could tell me what should I do next.
Sir, actually we just learned that a square minus b square is equal to a plus b whole, and then a into a minus b. So sir, we can use it into that formula.
Perfect. So a square minus b square is a plus b times a minus b. So here we have the difference of 2 squares. Again, I always say we are looking at the form. So something square minus another thing square. That's what we have here. So we have a formula for that. Something plus another thing times something minus another thing. Right? So here the something is a square plus 2b square, and here the another thing is 2ab. So we are going to use this. So this will be a square minus 2ab, or rather I'll just do it a little bit better using a square plus 2b square minus 2ab, a square plus 2b square plus 2ab. This is the product of these two things. So we have this beautiful factorization, and this factorization has a name. Can anyone tell me what is the name of this factorization?
Excuse me, sir.
There is a name of this factorization. Yes, yes.
Sir, I didn't understand this process.
Okay. This is a recorded session. What is your name? I missed your name actually. What is your name?
Sir, I am Ananta Shur.
Okay, Ananto, this session is recorded. Since this is a boot camp, we don't have the luxury of going back on something a lot. So if you did not understand it from the start, this is a recorded session. We will share you the recording and you can definitely check it. So this is a very famous identity. It is known as the Sophie Germain identity. Sophie Germain identity. She was a very powerful woman mathematician from Europe, and she discovered this. So this is a to the power 4 plus 4b to the power 4 can be factorized as a square minus 2ab plus 2b square, a square plus 2ab plus 2b square. Okay, so I'll give you a homework problem. The homework problem is that show that n to the power 4 plus 1 plus 4, so okay, n to the power 4 plus 4 to the power n is always composite except for n equals to 1. So if you plug in n equals to 1 in this, what do you get? Can anyone tell me? If you plug in n equals to 1 in...
It's equal to 1 plus 4. So
it will be, if anything,
that's a 5.
Then we get 5.
Yes, exactly.
Yeah, so that's 1 plus 4.
So
Sir, 1 to the power 4 is 1 and 4 to the power 1 is 4. So 1 plus 4 is 5.
Excellent, excellent. So this is a prime number, right? This cannot be factorized into anything. So except for n equals to 1.
Excuse me, sir, where will we show the answer?
So you will have to submit it to helpdesk@cheenta.com. I'll write it down in the chat. Okay. Submit the solutions once you are done to helpdesk@cheenta.com. All right. Okay.
So we'll mail it.
You will email it. Yes.
Okay, sir.
Okay. So that's great.
So within how many days?
Within the next week's boot camp. There is another one next week. So before that. Okay.
Sir, on this date only?
Yes.
Okay, sir.
Okay. So we have this first idea from algebra, and we really like how it's sort of unfolded in terms of factorization. The second thing we would like to do is understand something called the Pascal's triangle. Okay, so maybe you have seen the Pascal's triangle before, maybe you have not. So the way you do it is you start with a number, let's say 1, and you make it split into 2 of its own kind. Right. So you start with 1 and you make it split into 2 numbers of its own kind. So 1 basically splits into 2 versions or 2 incarnations of, yes, exactly. 2 versions or 2 incarnations of itself.
With the help of Pascal's triangle, we can find where a plus b whole square or a plus b whole cube,
Right,
a plus b whole to the 4.
Okay, just give me, okay. So now that you have this, let's do this one more time. So if we do this splitting process one more time, what would happen? Well, This 1 would become 2 ones. And what would happen to this particular 1? Can you tell me? And anyone tell me what would happen? Each step stuff
1 to 1. No, 1 to 1.
Okay, so before anyone speaks, you should be raising hands, okay? Because if you don't raise hands, everyone will speak and then there will be a problem. Okay, I'll go to Robo Beats. What is the name of this person? I've never.
My name's Pranjal.
Oh, hello, Pranjal. So, can you tell me what would happen to this particular one in the process that we are doing?
Yeah. So it'll add up to the center one over here. So this will become a 2.
So, first it will duplicate.
Yes, sir.
And then stuff that is colliding, that will
This will
add
get
up.
added.
So, this becomes a 2. Okay, that's
Yes,
awesome. Yeah, of course. So, what happens to the next step? So, who will tell me the
In
next
the
step?
same way, 1 is on the leftmost side, and then 1 plus 2, and then 2 plus 1, and then 1 at the rightmost side.
Okay, so but I told you, you have to raise hand, Ananta. Okay, and then wait for me asking you, because there others will be also trying to say this first, and then we will have a lot of commotion in class and we won't be able to conduct this properly, right? So let's do it in an orderly manner. Okay, so now, as Ananta rightly pointed out, this 1 will duplicate into 2 ones, this 2 will duplicate into 2 2s, and this 1 will duplicate into 2 1s, 1 and 1. All right, and now whatever collides, we add those up. Okay, so one thing that yeah, Anushka, go ahead, you have a raised hand.
I was just telling that it will become 1 3 3 1.
Yeah, this will become 1 3 3 1. Yeah, of course. Now let's do one thing. Let's try to add up the numbers in each row. So can you add up the numbers in the first 4 rows and tell me what is the result in the chat? So you can write it like this: row 1 1, because of course the sum of the numbers in first row is 1. The sum of the numbers in row 2 is 2, because you add these two numbers, you get a 2. The sum of the numbers in row 3 is 4, because you add 1, 2, and 1. So that's a 4. So like this, can you write in the chat the sum of the numbers up to row 6? Write it in the chat, sum of the numbers up to row 6. All of you. Okay. Okay, so we are getting some results, and we see that the numbers are like this. They are really 1, then we have, okay, maybe I can use black. 1 2 4 8 16 32 64. So who wants to tell me what pattern is being observed in each of the rows? Okay, so we have plenty of raised hands again. I'll go to someone with whom I have not spoken before. So let me go to Vihan Shah. So Vihan, what do you...
Yes, sir.
Yes, go ahead.
Sir, so here everything is like powers of 2. So 2 power 0 is equal to 1.
Okay.
Then 2 power 1 is equal to 2.
Okay.
And 2 power 2 is equal to 4. So it's like, let the row number be n. So 2n minus 1. So that's the pattern of the sum.
Okay, so nth row sum would be 2 to the power n minus 1, if you know what that means. That's great. So basically it is doubling in each step. So now I will ask someone, why do you think this pattern will continue given the fact that we have developed this thing with like this? So someone needs to tell me why this doubling thing is happening. So who I will go to? Dhruv Singhvi. I have not spoken with him. Let me ask Dhruv, why you think that this doubling is happening?
Because there are two duplicates of the particular number that we have at the beginning.
There are,
So
sorry?
it's basically multiplying by 2 every row because the number is splitting into 2, and even though the numbers together are adding, it still doesn't change the sum.
Right, exactly. Very nice. So it's basically splitting into two parts, right? Okay, so that is what's happening. Now let's do an experiment with this process. Instead of looking at this powers of these numbers, let's look at instead of looking at the sum of the rows, let's look at, okay, so 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1, something like this. Is we are getting something like this. Okay. Yeah. So what happens if you look at the diagonals like this? So something will be happening here. If you look at the diagonals like this, you will get a sequence of numbers which are known as the Fibonacci numbers. Maybe you have seen this before, maybe not. These are known as Fibonacci numbers. So for example, this is 1, this is 1. So you're adding numbers on the diagonal. Okay, so then you have 1 and 1, so that's 2. And then you have 1 2, that's 3. Then you have 1 3 1, that's 5. So you see a clear pattern of 1 1 2 3 5 and so on, right? Should be able to see this very clearly.
Yes, sir.
Okay, so now this particular sequence of numbers 1 1 2 3 5, what is the next number? That would be 8 8 13 and so on. So basically you're adding two numbers to get the next number. You are adding two numbers to get the next number, isn't it? That's what's going on here. So this particular pattern is known as maybe you have seen this before. This is known as the Fibonacci pattern or Fibonacci sequence. So what we are going to do is we are going to draw this thing. Okay, so let's do one thing. And I would ask all of you to do the same in your computer. So I'll give you a link to do this. So here we go. So this is the software that we will be using. Yep. And I will be sharing the board with you. So here we go. I've shared the board with you. And I'll just change this to new points only. Make the font size 16. Okay. So what we will do is we will be drawing the Fibonacci numbers in some sense. We will be drawing them. And once you see me drawing, I would ask you to draw as well. Okay. So we start with a very simple step. We take the Polygon tool. Can all of you see my board? You should be able to see it.
Yes, sir.
Yes, we are able to see it.
Use the Polygon tool. In fact, use the
Yes, sir.
regular Polygon tool. Instead of the Polygon tool, use the regular Polygon tool. Okay. So click on the first button, first point and the second point, and the number of vertices is 4. So you basically get a square. So can anyone tell me what is the area of this particular square?
One
Sir, 1 unit. 1 unit.
One
1
unit
unit
square.
square. 1 unit square.
Excellent. Very good. That's true. Let's do another one. Let's click on the Polygon tool. Just to make sure how the Polygon tool works, if I click on a point and then I go to its left and then I click on the number of vertices to be 4, what happened? What happened differently? Can anyone tell me? From
Sir, actually the area remains the same, only the position has changed.
So the position of the points, it has gone in anti-clockwise, and when we did it to the right, it went in clockwise.
right, exactly. So basically, this is following the. Okay, so if you do this A and B, then the next point will be here. Like it's like going anti-clockwise. So if you do like this, it's still going anti-clockwise because it'll go like this. So in a way, if you go from left to right, you'll get the square on the top. If you go from right to left, you'll get the square on the bottom. Okay, so a bottom of the segment that you've drawn. So I'll just do it one more time. Go here, and take 4 as the number of vertices. So you have the second one, right? Okay, so all of you can see this, right? All right.
So we also have to draw the second one, right?
Yeah. Please do the drawing as I am drawing, because I will ask you to share this particular workbook with me at the end of this process. Okay, done. Great. The next thing we will be doing is we will draw a 2 cross 2 square. Why? Because this is the first one. If first one represents the first Fibonacci number, which is 1, and the second one represents the second Fibonacci number, which is again 1. The third Fibonacci number is 2. Yeah.
Sir, I'm not getting the polygon one.
Okay, again, I cannot stop the session and go back and explain because this is not a normal class. It's like a camp. So you can always watch the recording and you can sort of ask me questions by email as well. Okay. All right. So right now, then you can observe. Let's go to the regular Polygon tool one more time. Click on D, click on E, and click on OK. So you see how I drew it, right? It's like, yeah, it's like now a 2 cross 2 square. You see that? Okay, so that's the third one, third Fibonacci number. So how can anyone tell me how would I draw the fourth one? The next one, how would I draw it?
So you will make a square with HE.
Yes, sir.
HE.
HE.
Yeah.
I could do that actually. I could do that. But yeah, I could do that actually. But I mean, if I want to do HE, then
It will only be 9 units.
so it will be 9 units. Okay, so we have this now. Okay, so what next? What should I do next?
Sir, join IK.
Join IK. Okay, let's go there. So should I go from left to right or right to left? Should I go from left to right or right to left to get the desired square?
Sir, right, left to right.
Left to right.
Right to
let's
left.
let's do that. Left to right 4. Okay, we got it. So what is the area of this one? This one is 25, right? Which is
Yes, sir.
which is 5.
So, sir, we are finding the squares of 1, 2, 3, 4, 5, 6.
So 1, 1, 3. This is the third one, right? And then, okay, 1, 1, 2. Sorry, 1, 1, 2. So maybe I can write it here. So we have 1, and then another 1. Then we have 2. It's fine. We have 3, which is the next one. Then we have 5. So what's next? What should I do next?
8. LJ.
Okay, so LJ, let's do LJ. So here we go. J. Oh, sorry.
Sir, other way.
I think I made a mistake. Yeah, of course.
Yeah.
Let's make it the other way. So LJ. Okay. So now we got it. So you're seeing the pattern, right? You are seeing the pattern, all of you. Now let's try to make the golden spiral. So what we will do, okay, I will quickly draw a few more just to make sure that, you know, it looks really nice. So MO. So let's do that. And then NP. So PN. Okay. Here we go. Okay. So now let's try to draw that spiral thing. So what I'll do is I will go here. I'll click on the circular arc tool and I'll click on the center DB. Okay. I hope you are seeing this. If you are not, that's fine. I'll be able to do it again. So click on this. BF. Click on that. So what to do next? Can anyone tell me? What is the next step?
So the center D and F to I.
Center D, F to I. Okay. So if that happened, if this is the order that we are doing things, if I could do it in this order. In that case, I would have to take the regular polygon in this direction.
Sir, I have a doubt.
Yeah, just a second. I'll come to you. So just go to the circular arc again. This time A, I, U. So I'm going to delete this particular polygon. Okay, just to keep the order of the spiral in the way we started it. So now I want to draw another regular polygon starting at U. Okay, the wrong direction. Maybe here. This is the direction. E to U. So that's 4. Okay. So now we can do the spiral one more time. So we have E, U to K. And then we can do this again. Can all of you see the spiral sort of coming to life? Should be able to see it.
Sir, I'm not understanding how to draw that arc.
So you select the point, which is the center, select the starting point, and then go to the ending point. And you should be able to see the arc.
Okay, sir, got it.
Okay. All right. So this is great. So your job as a homework is to share this with me. So click on this link, click on share, and you can do golden spiral and Fibonacci numbers, and click on save, and then you will get a link like this. So click on copy the link, and you can send it to me as a homework at helpdesk@cheenta.com, and this is the link. This is my link. Don't send me my link. Create your own. You may have to log in if you are just doing it for the first time. You may have to log in to the system. Okay, now your job would be to tell me the relation of so the relation of the arcs. So here it is. I'll write it down. How the length of the arcs are related to the Fibonacci numbers. Length of the arc pieces of the golden spiral are related to the Fibonacci numbers. Okay, so that is one question, and you send me also this particular diagram once you draw it. And one last thing I would like to share with you: if you are not an internal student of Cheenta, but you are sort of applying for just the Bose Olympiad, then we will be giving you access to the Cheenta Genius app. So you basically go to this link and you can log in with Google. So click on here, click on login with Google, and then you can just log in with your Gmail account. And then you can sort of start with problems, practice problems. Now, if you are not an internal student of Cheenta, you will not have access to this. So after you log in, you will see a few questions and things will stop. So email support@cheenta.com so that they can activate your account for the next 2 weeks. So ask for activation. Only then they will be able to activate it and you'll be able to see it and practice the problems. So do that. Finally, we will again have an individual round and a team round. So the individual round is coming up in 2 to 3 weeks, and the team round will happen after that. In the team round, there will be 4 people in the team, and those people can be inside Cheenta, can be your school friends, can be your, I don't know, some other friends, but they need to be of your same age group. You have to find your team members, otherwise you cannot participate in the team round. And at least one member of a team must be a participant of the individual round. And they should all attend the boot camp. So these are the rules. So I will be seeing you again next week with more mathematics. And till then, keep on practicing and send me whatever you want to send me. Okay? Bye, everyone. Take care.
Bye, sir. Thank you, sir.
Yeah.